Hi guys, Frankenstein here. Today I want us to look at this superposition question where you have to apply your superposition theorem knowledge on how to solve such a question. So we're gonna apply the theorem, and as we are solving the problem, hopefully you can actually grasp what's actually happening. So the superposition theorem says that you only consider the effect of one source at a time, and yeah, consider the effect of one source at a time. So if you have multiple sources, you remove them. Yeah, but now how do you remove those sources? So the way you remove those sources is that if you have a voltage source, you will remove that voltage source and replace it with a what? Replace that voltage source with a short circuit, and then replace a current source with an open circuit. Eh? And then after that, we're gonna start with the voltage source because we're gonna only remove the current source first, and then where there is a current source, we're gonna replace it with an open circuit. So there will be an open circuit right there. So let's do that. Check if it actually happens. So those are the two conditions you must make sure that you adhere to. That a voltage source you replace it with a short circuit, a current source you replace it with the what? With the open circuit. So let's try and maneuver around that. So let's draw the other circuit with the voltage source only. So that voltage source will be like this, keeping everything as it is. This is a resistor, by the way, guys. Don't say there's no resistor. So that's R2, that is R1, and you must leave that section there where we had to have that one current source. So there will be an open circuit right there. And that R2, then we have 12 ohms here. Then we have 6 ohms here, and then we have 36 volts. Now you'll agree with me that no current will be flowing in this direction. Current will be flowing in a loop. Current will be flowing in a loop just like this, right? So you can agree with me that I can actually cancel out this branch and remove it because there will not be current moving there. So I can actually remove that section. Okay, so I'll do that and remove that portion there. I don't know if it'll be okay. Yes, remove that portion. Why? Because no current will be flowing in that portion. And then now remember, I'm looking for the what? I'm looking. The question said that use the superposition theorem to find the current through R2 resistor, right? So I'm looking for the current flowing there, right? So you agree with me that this is the positive terminal, this is the negative terminal, right? So how are you gonna do that? You must find the current which is flowing there. But why? Because you're only considering the effect of one source. So you're gonna that current you're gonna flow is gonna be IR2 prime, right? Therefore, we have to have I2 primes. So we're gonna have to have IR2 prime, and we must have also IR2 prime prime. Now adding R, not adding them, but we'll decide on how we add them or subtract them based on the direction of current and based on the direction of conventional current flow. Very important. Now let's go about it. Let's go about it. So let's find the current there. So what we need to do, we agree that the current flowing here, sorry there, the current flowing through this resistor here is the total current, which is going to be the same current as there, right? So what we basically need to do is find the total current, right, flowing in the circuit. So first thing we need to find the total resistance. Therefore, R total will be equal to R1 plus R2 is equal to 12 plus 6. Find that to be 18 ohms. So that is our total resistance, R total, right? Now to find I total is equal to what? V total over R total, which is V total is basically E, so it's 36. 36 divided by 18. Make sure we punch that in our trusted calculators, guys. Very important. Now 36 divided by 18 is 2. Now we've got 2 amps flowing in our circuit. So I total, which happens to be I total happens to be equal to I R2, sorry, IR2 prime, right? Which is equal to 2 amps. Why? Because we said that the total, since the series circuit, so the current flowing will be the same throughout all those resistors, right? Specifically for this circuit, not this one, but this one. So now we have IR2 prime is equal to 2 amps. Now, where is it going? It's going down because it's going like this, right? Because conventional current flows from the positive towards the negative side, right? So we need to take that into account when analyzing this particular circuit. So down. So now we'll go and check another circuit which will be focusing mainly on the current source, right? Now let's draw the current source and see what happens. So we have replacing the voltage source with the short circuit, then everything will be the same. And then there it is. Then our current source there will be the same. Okay, there we go. Now our current source is 9 amps, and resistor is still the same, R1, R2. This resistor is 12, this one is 6 ohms, even though one is 12 ohms, right? Now here, how are we gonna find the current flowing through R2, right? What we need to do is we don't have to calculate total resistance, we just need to just use the current divider rule. What does the current divider rule say is that for me to find the current IR2, which happens to be I2, is equal to what? The total current, which is 9, multiplying by the opposite resistor, which I don't want to find, which is 12, divided by 12 plus 6, which that is 18. So let's find what is our actual current flowing into that resistor. 12. Okay, so we've got our current there is actually found to be 6 amps. So current flowing there is actually 6 amps. So we can actually see that the current flowing is flowing in the same direction as the first one, right? So what we'll do is actually add them together because I R2 prime prime is equal to 6 amps going down, right? So since they're going in the same direction plus plus, we'll add them together to find I2. So I2 is equivalent to IR2 prime plus IR2 prime prime, which that is equal to 2 plus 6 amps. So actually our current flowing in that resistor of the 6 ohm resistor is actually 8 amps. So just like that, we've actually found what is the current flowing in that resistor. Yeah, man, we've applied the superposition theorem successfully. Hopefully it was helpful. Cheers, guys. Frankenstein out.